So good morning, dear students. Today we'll start statical calculation of the metal frame in the program software LIRA SAPR. Actually, like in the previous our projects, we need to start with the initial dates. So let's look to the table number 1, and here we find the main information about our building, about constructions in our building, so which I will accept. Uh, Especially for this building, I will accept the last number of my ID will be, I think it will be 8. So 8 will be last digital of my ID. So for the beams, columns, foundation, or wall, I will accept initial dates according to the first letter of the surname, and I will accept from the S position. And the preliminary number, pre-last number will be also 8. So 88. So what I have? I have that the length of my building is 60 meter. The cross section, the length of in cross sectional direction also 60. There will be 9 levels. Each level has the height 3.7 meters. For foundation, in this case, there will be column foundation. So we know that in previous our project for monolithic buildings, the foundation was monolithic slab. So in this case, will be column foundation. So also there are monolithic slab overlapping with, sorry, with the thickness 150 millimeters. Okay, let's start. So we'll start from the opening new file, new creation of new document. So steel frame. Let's give the name like steel frame. Steel frame building. Okay. So what we need to go to the generation of space frames. Oh, I'm sorry. I opened the Russian version of the program. So I will quickly shut it down and open a new one. I'm sorry. Okay, now I will open LIRA SAPR 2017 because this version is installed in English language. LIRA SAPR 2020 is in Russian. That's why it will be not convenient for us. Okay, so we'll create a new document. steel steel frame building. Okay, so well, again, from the generates of 3D frames or special frames. So what we have? Here we have three main positions. It is for length of the building, for width of the building, and for height of the building. As we know, my building has the length and width 60 to 60 meters. It will be very easy to divide into 10 steps for 6 meter for each one, and in total we'll have the length equal to 60 meters. So we write here 6, the number of the elements will be 10, and the mesh will be 6. 6 meter to 10, and the mesh is 6. The height of one level is equal to 3.7 meters. According to the my initial date, I have 9 stories. I will accept 9, and the mesh I will apply 3. So here let's see. Um, Use parameters for foundation slab. So we're not need in the creation of slab. Divide for slabs. We also there are no reason. Oh, so we see that there are when I press the button for the generate floor slabs, you see that there will be no mesh. So I will tell you why there are no reason in this case create slabs automatically. Uh, that's all because we need to construct not only main beams like it was in the monolithic building, but in this case we need to add secondary beams. Monolithic building has the main beams in cross-sectional direction, so in longitudinal direction. So in both parts there was only main beams. In steel buildings we will apply uh, for one direction main beams, or maybe like in monolithic buildings, the beam which are connected to columns between each other will be main beams, and um, the beams which will intersect to main beams and be connected and supported by the main beams will be secondary beams. When we'll finish generation of main beams, secondary beams, we'll start uh, generation of the monolithic slab. Okay, so I press the button OK. So I have already finished 3D frame for my steel building. That's it. So what we'll do? Actually, we can start from the creating material properties. So we can add the stiffnesses for our main vertical and horizontal elements in our building. Okay, let's start looking to our task. I support you to start with the vertical constructions columns, then create the main beam, secondary beam, and only after then create the monolithic overlapping and monolithic slab, and then finish by the creating the column foundation. Okay, let's start. Columns. So in my case, it will be 40 K2. So I go to the stiffness materials and press button to add this stiffness, or add the section. It will be more right. Add the section of the beam or column. So for my beams and columns, I will be used I section. So I choose it by double pressing of left uh, button of the mouse. Then I go to the profile, and here I need to use the I-beam with the parallel flanges, the type K column, and here I choose 40K2. So here I can write the name of the vertical element column. Next, again I choose the I section, and in this case I choose it with the normal beams, because it will be for my second for main beam and then for secondary beam. So the section for my main beam will be 30 sheet 2. That's why okay, first of all, like I choose for the mm, normal beams, I will create the secondary beam. It will be 40 B2. 40 B2. And I will write here secondary beam. Then I will use the variant with the white flange I-beams, and here I will choose the 40 sheet 2. It will be my beam, main beam. Okay. Go next. The next will be overlappings. Overlappings. So for my overlapping, I will use the concrete with the mark 25, and here I will write concrete edit. Um, let's see characteristics 25, the model of elasticity. So I will write 306 and also 4 O's, 4 time of 0. Mhm. Okay, add 6, 1, 2, 3, 4. Okay, so for plates it will be the coefficient of Poisson will be 0.2. 0.2, right. The thickness will be 15 centimeters. Resistance density of the monolithic slab will be 2 equal to 2.5. So in the comments, I will write slab, slab, maybe monolithic slab, monolithic slab. What else? I can make the copy of this slab and will edit it. And here I will write monolithic top slab. So top it will be the last one of the 9 level. Monolithic top slab. Also, we need to add the stiffnesses for our foundation. So the column foundation consists of two main elements. It is vertical bar, so it is uh, under the column part, and the second one it is basement. So basement uh, are required to use for transmitting the load from the column foundation to the soils, to the ground soil. So let's add it by using the first of all rectangular bar with section. Let's see, here is can be found the requirements for foundation, for the column foundation. So I have size 2.4 to 2.4 meters. Okay, 2.4, 2.4. And the size for the column part of the foundation, I will use them maybe 1 meter to 1 meter. 1 meter, it will be enough, or maybe um, 800 millimeters to 800 millimeters, maybe 80 to 80 centimeters. So here I will write under uh, but column part. And also I will add the plate. It will be my basement. So it will have thickness 600 millimeters or 60 centimeter. Foundation base. Foundation base. That's all. So we already finished of adding the or fulfilling the list of stiffnesses types, and now we can add our stiffnesses at our frame. So firstly, let's choose the column. So the stiffnesses for columns. All of us remember the ways how we can select our frame. So first of all, we can use the option like select vertical bars, and from left part to right part select only vertical elements. Restore model. We can use option poly filter, and in the second place filter for elements we can go to the elements, for example bars. In this case, it will select all bars, horizontal and vertical. But in the orientation, if we'll use only Z direction, uh, it will select only vertical elements. Okay, so we'll use this option of selection. Okay, so we have already selected. Let's go to the column, choose the column, and now we need to add the style properties. So I actually recommended you to do it like I say to you, because actually you can just select, you can add only properties, but without additional properties. So additional properties and parameters, I recommended you to create immediately after you are going to add the properties, or in the same time. So let's go to the style. Let's look my to my task. What about Markov style? I have 285 for the style. So in this place I will choose 285. Additional parameters. For additional parameters. So for columns, let me 1 second. For columns, okay. We will use the conditions yn 0.85, and for buckling and strength will be 1. It will be principal column, uh, and here I can use the element 1, effective length. Press OK, and the selection limitations will be not changed by us. Now I press button on the material and apply our stiffness. Number of section, okay, will be 5. Okay. So we have already finished with the columns. I press buttons restore model. Then I go again to the bars. Um, Now I will select firstly all bars. Then I will select the according to the Z direction. So I see that now the columns are not selected, and press fragmentation. So here I have um, main beams. Here is only main beams without secondary beams. So creation of secondary beams will be made by us separately. Now we'll work only with the main beams. So I select main beams. Now I will use the third variant. It's by using the buttons Control A. So Control A, it's operation which I used in many programs. It helped us to select all things what are in the program. Yes, so I will use this Control A. Now I'm going to the material properties, select main beam, go to the additional properties, material for the beam. I will select the same like for the column. Additional properties for the beam in this case will be 0.35. For the buckling, here is the condition factors will be the same. Let me see. Four beams. Yes, will be the same. Okay. Right. Press button. Okay. Select. Okay. Okay. That's all. Materials, and we apply our section again for 5 number of sections. Okay. So finished. Restore. Okay, so what else? So before I will start adding the secondary beams, I want to do something with my main beams. What is it? First of all, I will select them and make the fragmentation. Next, I will again select them and go to the bars. In this case, I will need to create the structural elements of them, of all of them. Now they are structural elements. Being a structural elements, we can add the deflection fixities. So we'll use deflection fixities on the ends of structural elements. Okay, now we added, but not at all constructions or at all construction. Let's see. I will delete all of them. Or we'll try and again to see as deflections was created on all elements. Yes, it was created. Okay. Okay, now I will restore my model. And so what will be the next step? So the next step will be add the additional beams, so secondary beams. So the secondary beams will be added by us with the step 1 meter. So to do it, we need to make the copy of, or maybe just we need to add one especially node. So I will look information about this height 3.7. So I will use the option add nodes by the coordinates and will here write 3.7. According to the x direction, I will write 1 meter. And now I need to add this node in the opposite part of this beam. It will be equal to 6 meter in the y direction. That's all. Now I will choose the secondary beam, use the element, and will add the beam. Now I will select it, go to materials, steel, material, I will add the same like for previous ones. Additional parameters will be also the same. And the selection limitations will be the same. Material, apply. So now I can make the copy of this element. I will copy by the parameters to the direction x-axis. I will write 1 meter, and here I will write 4 time. So now I see that there are 5 secondary beams between main beams. Now I can select all of these four beams, and I need make copy for all my building. So I will go to the copy parameters. I will write 6 meter, and I will write, if I am not mistaken, 9 times. Yes, that's right. Again, I need to select all of them, and now in the cross section direction, I will be able to make the copy of all of them in the y direction. I use the copy in this case for y and direction, and the same time it's a 9 time. That's all. Again, I select all of them, and now I will make copy in z direction. Go to copy. I know that the height of my one level is 0 or 3.7, and there are 9 levels, so I need to add 8 times. That's all. And again I will select all of them and make the fragmentation. So now you see that we have already add all our beams, and then especially for this beam I will select them, go to the bars deflections. In this case I will create at each node, deflection at each node. So deflections was added. Restore the model. That's all for steel elements in my building. Now what I need to do, it is adding the slabs, horizontal slab, monolithic slab. So this monolithic slab we will create or generate by the hand variant, not automatically, like it can be done by us in the beginning of the creation 3D frame. Now, in this case, we'll use the option create regular fragments and grids. We go to the generate slabs. Generate slabs. Here we see two main directions, so x and y direction, x and y direction. So the length of my element will be 1 meter, and the number of times will be 60, as my length of my building and width is equal to the 60. In this case will be also 60, and I will show the point of the creation. So that's all. I have already added or created my plate, my slab for level. Now I can do it for all levels. So the same thing. Yes. So I show the node, required node, and add. There are actually another ways we can make the copy of our slab. You can do the